There are a total of 41 subtypes. Monthly Northern Hemisphere surface pressure patterns were analyzed by Bartzokaras and Maturzaks for January to February and July to August 1890 to 1989 using rotated empirical orthogonal functions to derive the major circulation types. In winter, pattern 1, 27 to 30% of the variance refers mainly to Europe and Asia, with a strong zonal circulation over the Northeast Atlantic and North Europe. Pattern 2 has an anticyclone over eastern Greenland and blocking over northern Europe, 21 to 30% of the variance. And pattern 3 features southerly flow over Europe and cold air masses over southern Russia and Siberia, 13 to 17% of the variance. In high summer, the two main patterns are a polar low pressure, 42 to 45% of the variance, and a polar high pressure, 42 to 44% of the variance. For summers prior to the 1930s, pattern 2 dominated. Since then, it has been pattern 1. This shift is correlated with a decrease in summer rainfall over northwestern Europe. There was no trend in winter circulations. Modern applications of synoptic climatology. The traditional uses of synoptic classifications are been illustrated here. More recently, several new directions have emerged. One is the application of synoptic typing to access general circulation model, GCM outputs. This was first used by Crane and Berry in 1988 in a study of observed and GCM fields for the Arctic. The MSL pressure fields were typed using a method of pattern matching developed by Churchhover and also by an EOF method. The simulated patterns appear quite realistic in both frequency and geographical characteristics, although the model data show greater extremes and more closed cells. Subsequently, there have been numerous studies of GCM simulations for past conditions and future projections, as discussed by Sheridan and Lee. In general, the observed and GCM patterns match better in winter than in summer. Also, interannual frequency variations are underestimated by GCMs. Multi-model re-ensembles, as well as individual models, have been used in the last decade, and sometimes ensembles produce better agreement with observations and sometimes not. Another area of application of airflow pattern or weather types is in accessing teleconnections patterns such as the NAO, PNA, and PDO. For example, Harriston and Crane demonstrated in the frequency of SOM nodes derived from eastern North America. Sea level pressure data is correlated with the NAO index. Johnson et al. Uses a SOM approach to examine the differences in the NAO circulation pattern relationship over the Northern Hemisphere and analyze changes in this relationship between 1978 to 2005. Several papers have applied synoptic typing to determine the structure of a given teleconnection, such as Castle et al. For the NAO. Okay, let's go to the summary. Synoptic climatology is the study of relationships between atmospheric circulation and local or regional climatic conditions. Scaled analysis in the 1930s to 1970s developed circulation type classification subjectively. Subsequently, objective numerical methods were employed using digital pressure and geopotential height data. These include correlation approaches, empirical orthogonal functions with clustering and self-organizing maps. Among the best-known and most widely used classifications are those of Huber-Lamb for the British Isles and the Grosswetter of Hess and Brzezowski for Europe. Both have been made into objective schemes and kept updated. An air mass-based approach, spatial synoptic classification, has been developed for local analysis of individual station conditions. Wagner, Gales, and Zdziszewski developed classifications of Northern Hemisphere circulation in the former Soviet Union since 1780. Only half of the variations in Europe climate can be accounted for by change in circulation type frequency. The remainder is due to within type changes. Zonal epochs in the Verningen-Grau Northern Hemisphere classification correspond to warm intervals, and meridional ones to cold intervals. Recent work has explored the use of synoptic typing in evaluating general circulation models against observation and the analysis of total connection patterns.